So we just did 2D shapes. Let's continue on with 3D shapes. Two-dimensional figures are flat, but three-dimensional figures pop out. So attributes are what describes the shape. You can describe it with the number of faces, edges, vertices. Faces, I say, are flat. Faces are flat. Faces meet to form that line. They form the edge. Edges meet to form the point, the vertex. And thinking of a cube, I think of a dice. Think about the faces on a die. There's 6 faces on a die, and so I double that to get the edges, the straight lines. So there's 12 edges, and I have 1, 2, 3, 4. 1, 2, 3, 4. So I have 8 vertices. A rectangular prism is a lot like a cube, but it's smashed and stretched out. So same number of faces, edges, and vertices. Faces on a rectangular prism, like a dice, that would be 6. Double it for the edges, the lines, 12, and then I have 1, 2, 3, 4. 1, 2, 3, 4. 8 vertices. A cylinder, I think of a can. So it has 2 flat surfaces, faces or bases, and the faces have to meet to form an edge, but are the faces touching? No, they're actually parallel, so they're not touching, so there's not any edges and any points on the cylinder. No, so no vertices. A cone, how many flat surfaces? Has 1 face or base. Well, there's not another face or base to meet to form an edge, so no edges, but it has 1 vertice, 1 point. Triangular prism, I think of a tint. So it looks like a tint. Or my most common example is the chocolate box. That's my most common real life example. I bought the box just for the triangular prism too. So a triangular prism has 1, 2, 3, 4, 5 faces. Think of a tint. 1, 2, 3, 1, 2, 3, and 1, 2, 3. So 9 edges and vertices. 1, 2, 3, 1, 2, 3. 6 vertices. A sphere, the easiest 3D shape. Any faces, any flat surfaces? No. Any edges? No. Any vertices, any points? No, that would sure be painful to play basketball with. So with pyramids, I say pyramids come to a point. They come to a point at the top. Prisms have a special prism test. If I were to cut my rectangular prism, think of like a stick of butter. Well, the inside would be a square just like the outside face. Or I could even cut it this way like the lid on a box. When I open it, the inside's a rectangle just like the top part. So a prism can be cut and the inside's like the outside. A cube, I could cut a cube any way, and no matter how you cut a cube, it's still going to be squares because a cube is made of all squares for the faces. A cylinder so badly wants to be a prism, but he doesn't pass the test. If I cut it this way, kind of like a stack of pennies or a can of cranberry sauce, the inside is a circle just like the outside, but it is a circle polygon. No. Also, if I were to cut a cylinder at the top, so if I cut a cylinder at the top, does the inside look like the outside? Well, the outside's curved, the inside is flat like a rectangle. So the inside doesn't match the outside. It doesn't pass the prism test. A cone, the same thing. I could cut a cone and the inside is flat but the outside is round. I can't cut a cone like that. That top part isn't equivalent with the bottom. So a cone is not a prism. A sphere, I could cut a ball in half but the inside's a circle and the outside is curved. So same thing, it's not a prism. Triangular prism, well, prism's in the name. If I cut it like this, the inside would be a triangle just like the outside. Or I could even cut it like this. The outside's a rectangle and the inside would be a rectangle. like a slice of cake. If you cut a slice of cake in half, well, the inside is like the outside that you just cut. Pyramids, they come to a point. They don't pass the prism test. They're pyramids. If I cut a pyramid like that, okay, it could pass the test. The inside would be a triangle, just like the outside on a square pyramid. But if I tried to cut the top off, the top isn't equivalent with the bottom. Same thing with a triangular pyramid. I could cut it this way, and the inside's a triangle like the outside, but I can't cut the top off and the top be equivalent to the bottom. So a pyramid is a pyramid, it's not a prism. They're not the same thing. Pyramids come to a point. So those are our 3D shapes. I hope you got something out of that. Just a quick review for everybody out there. Thanks for watching.